So we're going to be getting started. So what we're expecting today is, number one, the first thing you're going to get yourself acquainted with, it's linear regression. Linear regression, we want to demonstrate linear regression. How is this done in linear regression? If you're familiar with SPSS, you may have done it in SPSS, that's fine. And then you will know and understand and agree with me that when we are talking about regression, it's either you want to look at the impact of one on the other. Talking in terms of, you want to look at the impact of independent variables on dependent variable. It could be one-to-one. It could be one single independent variable that you want to regress against one dependent variable. So we're going to see. It's also possible for you to want to do multiple regression analysis in such a way that in a situation whereby we have more than one independent variables, you want to regress alongside a dependent variable. You want to look at the impact of those independent variables on dependent variable. Dependent variable is the one, actually, it's our y, which is depending on all other factors, which they want to see the impact on that dependent variable. So normally what we do is we do y is equal to I think the general equation, the general linear equation is about, I think, mx plus c or something like that. That's like the straight line equation for regression. And then what this is telling us is the y is our dependent variable, y the x is our independent variable. And we can, I think normally we do maybe b naught, I can't type it here, but let me just say b naught or b1 and then x1 or x naught. Let's say we have our constant, let's say constant plus our first variable, which is our b naught or b1, if you like, let's say b1, and then the is the coefficient of the first variable. The variable here is x1, that's the first variable, and the coefficient of x1 is b1, and then you also have another variable, say x2. So the corresponding coefficient of x2 is b2. So this is, you want to regress these two variables now. You want to regress variables x1 and x2 against y. This is what we want to do. x2. This is not programming. This is just trying to, do a kind of a general background or or introduction to the general equation of linear regression. That's what I'm just trying to do here. The first variable here, which is our x1, and then we have our second variable here, which is our x2. But in this instance, we have a b1, which is a parameter for x1, which is more or less like representing the contribution of x1, which is our target now, on y. And then we also have our x2. We have the corresponding parameter as well for x2, which is b2, which is what we are looking at for. This is what we want to see, what the value will be. This will tell us how much x2, for example, has contributed to the movement of y, which is a dependent variable. Or in the alternative, well, how x1, the how much, what is the quantum of the contribution of x1, which is b1 in this case now, to the movement of y, whether y is going up or y is forcing y down. That's what we want to see. Y now in this case is a dependent variable. So I'm going to begin to carry out the code now to perform this operation. Normally, what we do is what we want to carry out regression on, it's on your data. And we need to see what data do we have. Your data apparently has to be numeric. That one is standard. So what I'm going to do now is, I've already told us in the previous classes that even on the video that we have on the channel, that when you want to, there are two ways, there are major ways, apparently more than two ways, by which you can have data into your R. It's either use the inbuilt data set, that came with R. You can use that. I'm going to show us how to invoke that. I think we have done it previously. Or in the alternative, maybe you have your own data, apart from just practicalizing or practicing how to carry out regression analysis. Maybe there is a particular thing, a kind of a production data that you have, and you're expected to carry out data. Or maybe you are doing your thesis, and then you want to do your regression. So ordinarily you may have your data set in Excel or maybe in SPSS that you have saved as a CSV file which you want to bring into R. I'm going to demonstrate that to us as well. It's also possible for you to want to download a data from a data set online. It's also possible. I think I've demonstrated that as well. So, but today I'm going to quickly show us the two ways by which you can bring data into R, which is what we have done, and then we'll begin to experiment with the codes to get the regression done. So if you want to use the existing data, you want to know which data do exist in R, that's what you're going to click. You just type on data R and then you let it display what you have. So these are the data sets that are available, in R. These are the data sets that are available in R. These are the. So it all depends on what you want. If you want this guy, MPG, which is fuel economy data from 1999 to 2008 for 30 popular models of cars. If you want to retrieve that, all you have to do is this MPG is what you're going to use to call it up. So let's close this now. We already know, we've already picked one data we possibly want to use here. So I'm going to close this now. Okay. So I'm going to close this guy now, and then MPG invoke MPG. So when you type MPG and you just run MPG alone, you can see the content of MPG here. You can see the content of MPG here. I'm going to blow this up again so that we can see it better. Let's see. Okay, this is the content of MPG here. This is the content of MPG here. So, but then you can see the heading here. You can see the heading here. If you cannot see that very clearly, what you can do is to bring it, you can view it. Let's view it. Let's carry out a view on this. Let's carry out a view on this. I want to view this now. We want to view this. View MPG. All right. If that is what we have, this is a view. So from here you can see the headings. You can see all these headings are also referred to as attributes. These are the attributes, these are the headings, these are the columns. You can see that we have manufacturer, we have Audi, we have model A4 and all of that, different series. We have this display. What is this? Okay, so we have the year of manufacture, we have the cylinder size, we have the transmission. We have the transmission, which is represented by that, and we have the drive, whether it's a 4-wheel drive or all of that. So that's what we have there. So in that case, now what you now want to do is possibly you want to see whether any of these attributes or columns are apparently contributing to the consumption of fuel in the autos. Let's say this is maybe we want to regress the cylinder size, or the cylinder size is one of the things that may contribute to how vehicles do consume fuel. We already know that a V8 will consume more fuel than a V6. It's also possible for a V6. It's expected that a V6 will also consume more fuel than a V4. So that's what we have there. So we'll now want to check with I think let's see, the model of this is the model of the car, and then this is the, okay, we still have other ones. We still have other variables. I was wondering. Yeah, we still have other variables. So the variable here is this is the CTY. This CTY, we can apparently see the summary. We can see the summary of this. We can see the summary. Let's view the summary. We can see the summary of this in we can see, let's say, question mark MPG. So when you do this, when you write question mark MPG, you can get more information about that MPG. And if you look at this, this is what you have here. So it's telling us that this is a data set that contains a subset of fuel economy data that the EPA makes available on this particular website. And it contains only models which had a new release every year between 1999 and 2008. So this is the description of all the model. A data frame that consists 234 rows and 11 variables. I already told us how to do that. If you want to check what is the dimension, you see dimension of MPG to see what is the size, which is 234 by 11. 234 rows and 11 variables. Now, let's look at this. Manufacturer variable here, there. It is, okay, the model, the manufacturer is talking about the manufacturer name. The model variable, its model name. Display, which I was trying to remember, or, you know, what it is. It's an engine displacement in liters, you know. That's more or less like the consumption, yeah, in liters. So for me, I'm going to pick this as our dependent variable. Well, this is interesting. And then the year is the year of manufacture, because the year of manufacture also, if a vehicle is too old, that the likelihood that it to consume more fuel than a vehicle that is very new. So we want to say that we want to check whether year of manufacture will contribute to the fuel consumption, which is the display here. And then the cylinder, that's cylinder size, the type of transmission. And so I am going to use two variables, for example, here now. Let's use two variables that as, let's say maybe the year. We have already agreed that we're going to use display as a dependent variable. And then we're going to use the year as one of the independent variables. And then we're going to use the CTY. What is CTY now? Let's say is a city miles per gallon. All right, let's say city miles per gallon. We can also use HWY, which is highway miles per gallon. Okay, that's fine. We have so many variables we can regress with our cylinder, with our engine displacement in liters. So that's fine. So in that case, let's say let me go to you can create a new page to type in your codes from here. So when you create a new page, you can then say we are working with MPG data, MPG. You can now say, okay, that's fine. LM is a short for linear regression. So LM, you open brackets, you close the bracket. And then your dependent variable must come first, which in this case is our disk. I'm going to call our MPG dollar our display, something like that. That's our dependent variable. And then this will now follow by independent variable or independent variables. Let's start with one variable, one by one. So I'm going to go now, and there's supposed to be a sign which I'm going to put here in between the dependent variable and independent variables, which is tiled here now. So tiled, you find it on your computer apparently. So tiled, and then you put a space if you like, and then you now call for MPG. Like I said, when you do MPG, which is the name of your data set, and you click on your dollar, it will list all the variables within the data set for you. Now we want to pick, let's say we want to pick year. Let's say year, let's regress year, and let's see what is going to happen. So let's do a regression analysis, and then, but for me, I always like to put my output in a container rather than just run the regression and then just have it on the screen and I can't fall back to it. Okay, let's see. We can run this now. There you go. We have it here. This is our regression. You run this, which is the consumption, which is a dependent variable, and the independent variable, the year. We want to see what will be the impact of the year of the vehicle over the consumption. So this is what we have here. That's the formula that we have just rolled in. This is the only thing we typed. And then there you go. The intercept is given as minus 81.38. And then we have the MPG per year, which is the only variable, the independent variable that will regress against our dependent variable, which is the rate of consumption. So I am going to, before I begin to interpret, I'm going to do some other things as well. So that, but ordinarily, let me quickly interpret this. This is telling us that the MPG per, which is the year now, which is the year of the vehicle, is saying that 1 unit increase in the year of vehicle, will jack up or will increase the rate of consumption by 0.04% or units rather. Explanation about that. So let's move on. Let's add another variable. I want to add another variable now. We have already regressed that. But like I said, I always like to, because that is not enough before adding another variable. I think it's also important for us to see the R square, to see other parameters relating to the regression analysis, which is some of the outputs we normally have in all other application packages, you know, like SPSS, data, and all of that. So I'm going to put this in, let's say regress results. regress results. Okay, I'm going to put that in a container, which is then bring this here now. That's regression result now. Rather than giving us on the screen, it's going to put it in that container, which is what we have here. You can see regress result. So now if you now want to run this, you can double click this and run. It's giving us the same thing that we had the other time. At the same time, you can say summary. I want the summary of the whole thing of our regress results, which is this. Let's see what the summary will be. You can run that line as well and see the summary. So there you go. There you go. Here is our summary here. Here is our summary. Let me increase this. Okay, that's not increasing. Let me maximize it. So that's our summary here. You can see that our summary now is more elaborate in this case. So this is what we have here. It has increased the, if you look at this one now, this is the intercept, this is minus 81.36, and the standard error is given at 37.26, the t-value is given at minus 2.14, and the probability, which is significance, is 0.03, which is significant at 5% level, 5% error level. Yeah, this is significant. So you look at this as well, the real independent variable, which is our year, shows that 0.04 is the unit. I'm going to come back to that, and the standard error is 0.01, which for me is fine. The error it's minimal, when you compare it to the real estimate. And then the t-value here is 2.77. At the end of the day, the significant value is 0.023, which is less than 0.05. So which means this is significant. It is not by chance. Significant at what percentage? At 95% confidence interval, or 5% error level. Because if you look at this, this is less than 0.05. So now we then interpret this to mean that, like I've said, this is 1 unit increase in the year of the vehicle will increase, because this is positive. If it were to be negative, it will reduce. Now in this case, it will increase the consumption rate by 0.4 units. And this is not by chance. That's why we also found out here now that this is significant at 5% error level. So let's just see further. Let's see further. The residual error, it's okay, let's see the R squared in that case, which is the more or less like the goodness of fit. It's 2% here. It's showing us that the multiple R squared is just like R squared is 2%. And then the adjusted R squared here is about 1%, which is, and the overall, the F statistic in the overall is 5.18. And one thing I've noticed over time that I have been doing my analysis, that once your F statistic is 5 over, there's a likelihood that it will be significant. So when you check the significant level in the overall, you also find out that the overall is also very significant, which is 0.02 less than 0.05. I'm going to include another variable now in this case. Rather than me carrying out regression on only year, I want to include another variable. So when you want to add another variable, you are not going to use comma to separate them, but rather you use plus. The plus is not to add them together, but the plus is to include another variable. So you're going to see MPG, your $sign, and then let's say cylinder. Let us check what the impact of the cylinder will be. You click on cylinder, and then let's see what we're going to get. So I'm going to put this in result 2 now, and then we can also summarize result 2 now, so that can generate another object for us. Let's run this together. There you go. Our result 2 is also here now, waiting for us, result 2 waiting for us to inspect. I can click here to see what are the things that we have there. This is showing that we have the numeric variable, and then we have the, okay, let's go. Let's now switch to where we have our summary result, which is in this place. So I'm going to magnify that again so that we can see it better. Oh, okay, I'm sorry. Page, this is the results page after we have regressed both the year as an independent variable and the cylinder as an independent variable. Don't forget, against display. or more or less like against the fuel consumption, which is DISPL in this case. So if you look at this, if you look at the estimate here, let's look at the year. The value for the year has changed. It has reduced in size. You know, previously it was 0.04. So in this case now, the cylinder has impacted even the performance of the year. Now, the cylinder now in this case has reduced the impact of the year. It has reduced the impact of year on the rate of consumption. Let's move on. Now, let's see the impact of cylinder itself, the cylinder size, cylinder 4, cylinder 6, cylinder 8, and all of that. So this is telling us that the cylinder has a greater impact on fuel consumption than the year of the car. So this is telling us that the interpretation, 1 unit increase now in the cylinder. Maybe you move from cylinder 4, ordinarily there is no cylinder 2, cylinder 5 rather. If you move from cylinder 4 to say 5, then by 1 unit, if this is increased by 1 unit, if the cylinder is increased by 1 unit, it will jack up the rate of consumption by 0.74 units. You know, 0.74 units, which means if you have been covering a distance with 1 liter, and you now increase the, if you have been using 0.4 liter engine, you now move to 0.5 liter engine, it's going to add 0.74 units to your previous consumption. This is what it is saying. So this is adding to consumption, which means cylinder, the value of cylinder has great impact on the consumption of fuel in a given car. If you look at the standard error, it's saying that this is not by chance. The error is so minimal. So there are no noise in the data for cylinder, so that in case you may want to say that maybe there are noise, that are outliers, in the cylinder, that's why we're having this challenge. No, this is the standard error is giving us an instance, giving us a glimpse that is not the case. Now the T value here, you can see, like I said, once your this is T value. I'm talking about the T value is also, when the T value is also high, there's a likelihood that the variable is likely to be significant. If you look at this, this is written this in standard form, which is like 2 times 10 raised to power minus 16, which is 0.000000, up to 16 zeros. So this is telling us that this is significant even at the barest minimum. This is less than 0.05. This is less than 0.00001. So summarily, this is saying that the is significant. But then I like us to draw, so that we want to see the R squared. Let's see which is the goodness of fit for this particular model as well. Let us see what the R squared will give us. To run the R squared, you have to do summary of that result. And I think the R squared should be there. Why is it not showing us there? Okay, it's there. It's there apparently. It's there. The R squared is already there. So I am going to see if I can. I'm struggling to ensure that you can see the screen. So the multiple R squared in this case, yes, if you look at this, the residual error is this. Okay, the R squared is 86%, or approximately 87%. This is 0.87. 0.87. That's huge. This is very, very huge. This is huge. Let us see how we can blow this up. If you look at this, this is huge. This is the R squared is 0.87, which is 87%. And the F statistic is large as well, which is about 750. So and then you look at that, the p-value is this. So which means indirectly, I'm also trying to carry out what we call is it hierarchical regression? They call this. By which you'll be adding, when you're adding values, when you're adding, when you're adding attributes, you are adding columns to your regression model. We have done two models. Now the first one was to carry out the regression model with only one. Okay, let us view. Okay, let's look at the names of MPG. That's what we're going to have. Okay, there you go. We have the manufacturer. Okay, we have the manufacturer, we have the model, we have the display, we have the transport. Okay, so let's include the, let me see what is drive. Is drive. Okay, I also want to see the whether, let me look at structure. Okay, let's say class of MPG. Okay, MPG, you can also see it from there. Okay, let me look for the structure. I want to see whether DRV it's in structure. Okay, let me see MPG. Okay, so here we can see this. We can see whether one is character, the other one is numeric. So I think okay, I don't want to. You can't regress character. It is a numeric or integer. So I'm going to use I think this is city. City is also integer. So let us regress city alongside with those two that we have done previously. So I'm going to include city is city-y. So I'm going to form another model. I'll call it city-y. So I copy that. I want to make it model 3. Okay, ordinarily, like I said, we can say model, not just regression results. Okay, this is model 1. Okay, this is model 2 apparently. This will now be model 3. Okay, so we're still maintaining our display as the dependent variable, and then we have the year, we have the cylinder, and then we are going to add the third one, which is our MPG $, I think city-y. Okay, that's fine. Let us see what that is going to give us as well. There you go. Our model 3 gives us what do we have here? Okay, let's try to summarize it. Let's summarize it. You can even run that before the summary. Model 3. Let's run that line. This is our regression. You know, these are the values. Yeah, this is a very interesting one. It shows that this one has negative relationship with the consumption. The city-y, what do we say the city-y is? I'm so glad we still have that. That's city miles per gallon. Oh, okay. So that means city miles per gallon. It means it will cover less cities per gallon. 1 unit increase in the city. Okay, 1 unit increase in, as you are advancing, covering more cities in terms of covering more kilometers, there's a likelihood that it will drop the consumption by these units. Wow, this is interesting. So I am going to do a summary of that. Let's do a summary of that. Okay, let me put it in the summary of our model 3. Okay, let's see the summary here. There you go. We have the summary here as this. So here are the parameters for year as an independent variable. It has also perturbed the days as well. It has affected the year again because this guy is just joining them. Another variable is joining them, so it's forcing a change in the way all other independent variables are also going to perform. You know, so this one is 0.01 as opposed to the previous data that we have. So the consumption rate here now the cylinder now, 1 unit increase in the cylinder in this case now, because we have 0.64, will increase the consumption by 0.69 because there is an intervention of city-y, which means there is a reduction now in the consumption relative to cylinder. Even if the cylinder you using whether you use V6 or V8, this is saying that because of this additional variable, it has forced this down when you compare to model 2. So what is saying in essence, and I'm going to let us see as well, is that you can compare these models together and report them in your thesis or whatever you want to do. With this single table that we have just generated, you can write about 2 pages of reports from here, starting from reporting about model 1, what has happened, going to model 2, going to model 3, and then you can place them side by side from top to bottom and then prove the parameters, because we have different R squared values for each of them. You can also pull all the F statistic. We have different F statistic, and then you can report these based on different models that you have generated. So let's look at the F statistic here for this model. This model now has 3 independent variables. So this one is saying that the R squared now is 87%. So which means the higher the R squared, the better. The higher the R squared, the better. If you look at the first one that we generated, that was alone, the R squared was, I think, less than 1% or thereabout. The second model, which is our model 2, the R squared also improved from the previous one significantly. It's about 70 something thereabout. Now, the third one, because we have generated another model by adding a third variable, that one has also jacked up the overall goodness of fit by some level as well. It has increased it. So, summarily, we now have 87.4% R squared for model 3. In this instance. So this is showing that this is interesting. And then, do we want to say whether this is significant or not? Yes, looking at this as well, again, it's significant. This because this is still less than 0.00000001. So that is the model. So it means all the 3 models are indeed significant. And then you can report model 1, compare to model 2, compare model 2, compare with model 3. This is the way regression is done in R. This is interesting. Very excited about this. All right, that's fine. So I'm going to bring in another variable. Another data set from where we used to have in case you want to bring in your own data set into R for analysis. So this is what I'm going to demonstrate. To get that done, if you like, you can open another page here, or you can even leave it at that. You can still work there. So I'm going to say I want to CSV. Read the CSV. It's a CSV file I want to open. I always like to use this because I don't have to be racking my brain. Where is the folder? I don't have to rack my brain about the path of the folder. So I'll just say file choose so that this can allow me to choose wherever that file is on my computer. So what I put file choose, and I'm not going to put any. I'll as well put other parameters like say string. Like say, header, does it have header? Header, yes, it has header, and then the header is true, and then comma, are the strings declared as factors? No, false. All right. Do we also say that it has separators? Separators. Yes, it has separators, which is what do we call it now? Comma. So you put this in inverted. You put it in comma as it is, and there you go. You just run that, and let's see what we have. So it's bringing out a dialog box for us, asking you to choose your file. I think the file I want to use, I have it in Match Special, I have it in R class, and I like this customer file. That's what I want to open. So once I click on that, it's already open into the memory of the computer. But then I can't do anything to it. If you look at this, it's already open here, telling us that, the file is open here in the here. But then that's not enough. I want to put it in a container. So I'm going to write a name for that file. Let me call it, it can be any name. Let me just say cost. Although it's customer, but let me leave it as cost. So I open it again. I pick my file from Match Special. I click there. Cost. You can see that now cost is here. I look at that dimension is 2000 observations and its variables. So you can do a dim of that to confirm as well. Dim cost. It's telling us it is 200 by so, which means it's correct. 200 of observations and eight attributes, 8 columns. So that is what we have. So you can also want to view. Let's view, so that we can let us view. Let me write it here. You want to view cost. Okay, cost, which is the customer data set. This is what we have here. Customer data set, we have the heading customer ID, we have gender, male and female, we have age 19, 21 and all of that, annual income, we have the spending score, we have the profession, healthcare, engineer, lawyer, entertainment, artist and all of that. And then we have the work experience 1 year, 3 years, 0 experience 2 years and all of that. And then the family size 4, 6, 8 and all of that. So that's what we have. So in that case, what do we want to do again? I can move on to begin to do a few things with that. Ordinarily, let me demonstrate regression for us there again, and then I will do a few other things there. Let me see, what do we regress? Then I want to see the properties of these variables. Ordinarily, I can see that age is numeric, and then annual income is also numeric. So all of these we can regress it against each other. Spending score can also be regressed. Work experience can also be regressed. Family size can also be regressed. But how do we can we say that, okay, what do we regress? Which one do we make a dependent variable? We can say annual income. What are the things that can impact annual income? I think annual income will be fine for us as a dependent variable. We want to check whether the gender is a determinant for whether increase or decrease in annual income. We also want to check whether age is a determinant for increase or or decrease. The billionaires in the world today, I don't think we have a list of somebody who is less than 40 years or 30 years among them. So, which is suggesting that the older you are, the more likelihood your annual income, your income is likely to be getting bigger, getting fatter. But then we don't know what we have in this figure. We don't know what we have in these data sets. Let us inspect that. So when you do that with regression, we can then confirm whether that assertion or hypothesis that age would definitely have impact on income. That age has significant increase in or impact on, or rather in generating more income. So we can confirm that if that is the case in this data set. So what I'm going to do is I'm going to regress both age and annual income together. So then our annual income now in this case will be our dependent variable. So how do we go about that? We do our lm brackets open bracket close, and then our data set is a cost. Don't forget dollar. Then our annual income is a dependent variable, and then our tide has to separate that. So I put a tide here, that's still in between the tide here, and then the other MPG, is not MPG, this cost this time around, then dollar sign. We want to regress it with age, that's fine. So let's see what this is going to give us. So let's also label this as model 1. I think it's only one model we want to run here, and then we can move on. Model 1. Okay, so let's see what that is going to give us. Okay, model 1, or let me say model 5, because I don't know whether it's mixing it up with others. Okay, model 5 is there. So this one has done it. So I want to summary of model 5. Model 5, so that we can see what we have. Model 5. Okay, model 5, there you go. That's a summary of model 5. So if you look at this, let me magnify that. Okay, so this is we have attempted to regress where is it? Okay, we have attempted to regress annual income, regress age with annual income, and here comes the output. The output is telling us that it's also giving us some other parameters, that the minimum is this negative, and the maximum for the annual income. Annual income is 80,420. If that is in dollars, I don't know, that's fine. And it's giving us the median here. It's also giving us the third quarter and the first quarter. But then where our concern is about it said there is error with t value. So which means that it's not giving us there is error with the data. Let's see. No. Okay, it's there. It's there. I think we have it. Residual standard error, okay, is this. All right, on 198 degrees of freedom. Okay, that's fine. But our multiple R squared is very, 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 very low, which means this, you cannot rely on the output of this model. This model may not be reliable because the goodness of it is so slim. It's so slim. But then the F statistic is 0.9, just like I said. You know, it's not up to 4, it's not up to 5. If the F statistic was about 5, there's a likelihood that it will be significant. If you look at the significance they have now, which is the p-value, is not less than 0.5, 0.05. It's also not less than 0.01. So in this case, this is not significant. So that means in this case with this data set, age, it's not a determinant of income. So it means somebody who is less than 20 years, a teenager, can even be a billionaire. In that case, that's what it means. So that is just that about that. And I think let me quickly move to doing a few things with data wrangling, also with the same data set, and then we can close for the day. So okay, let us say that you want to do, we won't be able to do much today on that, but then we'll try as much as possible to use 1 or 2 commands, and then we'll be fine for the day. So let us say that, let me put this down. You want to use Tidyverse library. You must have installed Tidyverse. This is the caveat. You must have installed Tidyverse. It's a package which is usually used for data wrangling in R. So you are expected to have installed the package on your computer. If you don't have it, this is how to get it installed. I've explained that in a previous video in the last class. Go to Akada Virtual Lab and check the video that we did last week on data wrangling as well using R. So you'll find that there. But then I'm going to still demonstrate one of the methods for you here. So you just install the packages, and then you just put it in quotes. Okay, you say Tidyverse, and then you just run that. I don't want to run this again because I already have it installed on my computer, and I don't want it to, it will take some time to get it installed, maybe like 2-3 minutes, and I don't want to hold us to run. So I move on. So once you have installed that package, the next thing now is to bring it into the memory by calling it up and say library Tidyverse. There you go. So you have to click on this you have to run that. Once you run that, then you are good to go. Okay, let me see. Okay, it's ready for me. So all the commands, the objects, the functions that have been embedded in Tidyverse, we can now begin to use them. So we already have our data cost, which is our customer data, something like that. I think cost is a cost. Let me see what we have. Okay, let me see the name. Let me look at the parameters names. That's how to check the variables on top of your data set. Okay, that's fine. It's cost. Our data set in this case is cost, C-U-S-T, which is a short for customer. I just try to do that so that you will not think that the name of that folder, the CSV, has to be the same name that we use here. No, I was just using that to delineate that. So names will give us the attributes, the columns in the data set. So here we have customer ID, we have age, we have spending score, we have work experience, we have gender, annual income, profession, and family size, all of that. So when you say names, customer, that is what we call pipe. You can invoke it is Control-Shift-M. So this is this. This is it. This pipe. This is pipe. This is what we call pipe. I'm going to tell us more about that later. But it is one of the key operators in Tidyverse. You need to do that. So now that you have to. Okay, so let me do this. That's the data set, the name of your data set. You are telling the computer, this is like, I see this thing like SQL. It's saying that computer use cost, this variable, this data set called cost. And then the next thing you have to do for me is anything, this pipe operator, interpret it as then, and then go to customer and select Select what? What can you select? You select those variable names that are present in the names in the data set. Select name, select age, and what else again? What else do we have there? I think we have okay, we have gender. Okay, let's say gender. Select, okay, gender. Okay, there you go. So you have to run it together so that you understand that the first thing you are doing is, oh, you're asking me to use this data set cost, then select age and gender. What I want to do is to subset that entire cost data set. I want to just separate only age and gender. You may want to do other things with that. That's the way you're going to do it. So I want to just do that. I'm going to click on, I'm going to run that. Yes, I've run that successfully, but then it's not showing, it's not, okay, that's that, there you go. It's showing us there, it's showing us there, it's showing us there. But I always like to put it in a container, like I said. So you can also say that, put that in a container, selection, let's just say selections. Okay, we just selected a few. So you put that in a container, and then you can, well, I can just say another, let me say data set, data special. Let's just say special. Okay, that's fine. That's the name of that data set. So once you have done that, you select it and put it inside data special. So it's still 2000 observations, but only 2 variables are selected. And that's what we have just done. In the alternative, don't forget again, you can just say, you should select, you can also want to negate, you want to remove some, if you want to, you don't want this to be there. I want to negate, don't include age, that's minus age. Then don't include gender in the entire data set. So I'm going to say entire. Okay, data entire. Enter. That's another data set now. But this time around, it's going to list all other variables. It's going to select all other variables but without age and gender. And it's going to store it in data enter. You can see the entire data set says 200 by 8. And in this case, it has removed, 2000 observations and 8 variables in the original one. So it has removed age and gender from that data set, and it's giving you another fresh data set which has 6 variables. So if you view this now, you agree with me that you won't see age and gender. Data entire. Okay, let's run that. You must not see age and gender. Can you see? Can you imagine that? Can you imagine that? That's what it has done. So the first thing they will do for you when you are going for any interview in data analytics, the first thing, they will give you a data set and ask you a number of questions. They will list, even when you want to write an online exam, this is what they will do to you when you are carrying out your test. They give you a data set and then list a number of questions. Can you select those using computers? Can you select those male students alone in the list? They may even ask you, can you select only engineers? Now, in this case, now let us select engineers. Let us, in this data set now, which one is, okay. Okay, let us select artist in profession. So, to select that, we want to select artist now in that data set. We're done with the previous one. We're going to use the entire one, which has the overall, what do we call it now? The cost, which has 200, okay, which has the dimension of cost is 200, 2000 by 8 variables. So we're going to use all the 8 variables. But in this case, we want to select profession alone. We want to select profession alone with those that are just artists. Select those that are artists alone in the data set. So what we're going to do is we're going to filter. We are going to filter. So we are going to filter. So you are going to, let me come fresh again. I'm going to say, okay, this is it. Let me copy this. This is what I will need. I will need this guy. So this is the code to get that done. I'm going to say I'm using the dataset customer, then filter. Now this is telling us what to do. It's saying the filter. In your filter, you're going to put the name of your data you want to filter. And then thereafter, what you're going to do next is you are going to now say, okay, let's see. I want to filter, what's the filter? I think profession. Profession is profession. Let me see the way it is written. Let me check the way it is written, and then I will just use the profession to bring that. So I may not bother myself with this. That's just to inspect the way it is written. Profession that are equal to artists. Okay, there you go. It has selected it, but then it's important for us to put it in a container. Let's just say artist. Okay, artist. Put it in that container called artist. So let us see that. If you like, you can close this. I want it to be clean. Okay, and just say artist. So it's already saved inside artist. So how many of them are artists? So we're going to view it now. This way it has selected only those, selected all other parameters with people that are just artists. So this is selecting 612 out of 2000. So let us view that. Let us view artist. Okay. There you go. You can see only artists are listed. So Tidyverse is very friendly. It's very interesting. You can also do the same for any numeric figure. Maybe you want to say, okay, those whose ages are maybe greater than 30. Let's select those whose ages are greater than 30. Let's say. Okay, you can also say, okay, select by age. Let's copy this, and then we'll replace that. We just want to age now in this case. Age, let's just say age selection. Okay, still using the same data set. Then filter by age. When age is equal to or greater than, I like greater than because greater than 40. So let's run that. There you go. Age selection, we have 1,145 selections. 1,145 selections. So if you view that, let us view age. Put age here. Age selections apparently. So we run that, and let's go to the table and see what we're going to have. There you go. You can see now that we have selected that anything or anybody whose ages are greater than what now? 40 here. There you go. 40. You can see now. You will not have anything less than 40 here. Less than 40 here. Less than 40 here. And it has counted it for us. And it has counted. This is so intelligent. So this way, there is no examination you want to carry out with data sets, manipulating data sets, you would not be able to do. It is so impressive. It is so interesting. It is so impressive. It is so interesting. And there are much more that we can achieve with that. But join us again next week for more exciting interactions. We're still going to do more with Tidyverse next week, and we're going to do a few more things in the session as we gather next week. Don't forget to subscribe to our channel if you have not done so before. Make sure you like our videos, subscribe to our channel, and share with your friends and colleagues. Let them come here every Friday, 5 to 6, to learn tricks about how to use R.